part on process lifecycle management. As you all probably know, this is a quite important part of Windows 8. Your Windows 8 applications can be in different states. So your Windows 8 application can be running, can be suspended, can be not running. And the general idea for this is that while in previous regular Windows applications you could have 2, 3, 4, 10, whatever applications running next to each other. Now for Windows 8, these applications will be running on tablets, which might be ARM tablets with not a lot of memory, not a lot of CPU power, etc., etc. And of course, we want the end user to keep and have a good experience. So your applications don't really keep on running at the same time, although we do want to create the impression that they keep on running at the same time. So what actually happens is once a user switches away from your application, that application goes to suspended state. Now, suspended state is still quite easy for us to work with because you actually don't have to do anything with it. Once your application goes to suspended state, there's actually a big memory dump that's kept in mem, and once the user goes back to your application, that memory dump is activated again and your user can continue using your application as if nothing happened. So that's by far the easiest way because nothing has to happen. However, an application that is suspended could get terminated. Now, how is this chosen? Well, actually, Windows chooses this for you. So an application that goes into suspended state might be terminated at any point, at any time, while the user uses the tablet or the laptop. It depends on the memory footprint, it depends on CPU, the other applications needed, etc., etc. But you have no control over this. So at any time, your application might get terminated, which means the memory footprint is totally discarded, which means next time your user gets back to the application, he doesn't just end up in the application as he left it off, because it was terminated. So this is where some programming comes in. This is where we need to make sure that the user gets back to the application as if the application kept on running in the background. So this is where we have some work. So this means that, in essence, when an application is suspended, you should ensure that all the data that is needed to give the end user the impression that your application keeps on running in the background when he switches back to it, that all that data is saved somewhere, to get all that data. Because you are notified when your application is suspended, but you are not notified when your application is terminated. So you do not have any control on what happens once the application gets terminated. So let's have a look at what events you have to ensure you can work with this. So when your application is activated, the onLaunched method is executed. You can override that one. That's in app.xaml.cs. When you go from not running to running state, that's where you end up in. When your application is suspended, you go from running state to suspended state, and then you end up in the suspending handler. So you handle this.suspending on app.xaml.cs to typically save some data. In this case, to save the data you need to ensure your user gets back to the state he was in before. Now, I say save some data in the suspending event handler. That's correct, but often for big applications you will want to save state at other places in your app as well, because you only have a limited amount of time. I think it's about 5 seconds in the suspending handler, and if the code that is executed is not executed in those 5 or 10 seconds, your application is terminated. So your code is typically, your data is typically corrupt at that moment because your app wasn't able to finish saving it. And the next time your application will start up again, well, you will probably have to start from zero again. So save state in suspending, yes, but only save a limited amount of state there. A tip, how do you save state if you need a big amount of data that needs to be saved? You can also save state when navigating from page to page. That's something that typically happens. That's built in by default if you use the built-in suspension manager. I'll get to that in a minute. But often for bigger applications, you will, of course, want to write your own way to handle saving state and saving data, local object store, etc., etc. Suspension manager is great for getting started, let's say. Now, you have suspending. You also have resuming. So resuming is where you end up in if an app has been suspended and the user goes back to the application. Now, very important to know here, you end up in the resuming handler if the application hasn't been terminated in the meanwhile. So the resuming handler, actually, a lot of the time you don't have to do anything in there. Because as I said before, if the user gets back from suspended state and resumes his application, that's actually a big memory dump that's used again, and your app is exactly where it left off. So why would you use this resuming handler? Well, imagine a newsreader application. And imagine your user using that application today. And at a certain moment, he starts doing something else. So this morning, he was reading his newspaper on his app. And he starts doing something else. And tomorrow, he comes back. Now, if he didn't really do a lot, that newsreader app's memory footprint will still be in mem. And the user will go back to the application and go to the resuming handler. So it will go from suspended to resuming. If you do that, your user will end up with news that's out of date. So the resuming handler would, in this case, be a good place to say, well, I'm going to check somehow, somewhere in the application settings, for example, or session settings, keep the date when it was suspended. And if you resume and say the data is more than 2 hours old, just automatically refresh the articles of the newspaper. That's one of the ways you could use the resuming handler. Okay, then what should you do when? These things I told you were all when you still have your memory footprint. But at a certain moment, your app might get terminated. So bye-bye everything that's in mem. You only have what you saved in the object store application settings. Your application could be terminated for a number of reasons. Probably the one that will happen most is the system terminated because the system needs more resources or because it's shut down or something. That means that when the user starts up the application again, he doesn't end up in resuming or whatever. He ends up in onlaunched. And in this onlaunched method, you can check what the previous execution state was. So you can check if the reason your app was terminated, for example, or the reason your app was out of memory is that it was terminated by the system. Then it will have the value terminated. And if that was the case, you should restore the user to where he was before and load the data from your object store so the user gets the impression that he never left the app. Now, of course, the user can also have decided to close the application. In that case, you will have the closed by user as previous execution state. And then you should, of course, start with default data. Same goes for if the application simply wasn't running. You should start with default data. So these are a few events and handlers you can use for your application state, for process lifecycle management, and the things you should do when you end up in one of them. It's actually, once you start working with it, this is actually quite easy. It's, in my opinion, a lot easier than what we used to have with Windows Phone, for example. If you've worked with that, this is a bit easier. Okay, so there are, of course, a few guidelines. So let's quickly run through them. Generally, resume your app as the user left it instead of starting it fresh. So that's the general idea. The user should have the impression that your app just keeps on running, while it in fact doesn't. As I said before, with the newsreader example, if your app has been resumed for a long time, and depending on the application, it could be a good idea to automatically refresh the data that's shown in the application. In a newsreader app, you would typically want to refresh the articles so they are up to date. When the application is being suspended, you should save the application data. And of course, release some resources, file handles, and you don't want to keep them hanging around. This is more about what you should do when your app was terminated. So if your app was terminated and you resume, you do not end up in resuming. Bit confusing maybe. But if your app is resumed after being terminated, you end up in unlaunched. So there you check what the previous execution state was, and you restore the application data, and you typically also restore the place your user was in the application, so the view he was on. And well, if you cannot predict whether the user wants to start fresh or not, you could ask him for it. That's only for some applications, but that's also one of the guidelines that's used. So those were a few guidelines. Now, what do you save and when do you save it? Because this now it becomes a bit difficult, a bit confusing even. First of all, you have application data. So what can application data be? That's typically application settings. Application settings like how many articles do you want to show on the page, or how many articles does the app has to show on the page, to be more exact. For these, you can use settings. There's roaming settings and local settings classes included. Those are actually just dictionaries of items. I will show you. And these are persistent across sessions, and they should always be accessible to the user. So that's the application data. You can, of course, also have other application data. You could, for example, imagine, well, I guess the typical example would be code table data. Code table data that's very rarely refreshed. You could see that as application data. First user who starts it downloads that. After that, it's used from the object store, for example. Then, of course, there's session data. And that's data that's specific to this user session. For example, in the newsfeeder application, the article your user was viewing last time he left the application, that would typically be session data. That's not application data because, well, next time you start up the application, that's not where you want to end up. It's next time the user gets the impression, he resumes the application. So the place where he left off, that's typical session data. And another tip, there's if you use layout-aware pages, which you get when you use the default templates, there's actually load state and save states events on your views already. And these are automatically triggered on navigated to and on navigated from. So you can easily use those to load or save the state of that specific page if needed. And that in the backend uses a suspension manager. So then we of course go to the suspension manager. What is a suspension manager? Well, actually it's something that's included, a class that's included in your Windows Store applications. We'll immediately look into that a bit. And this class actually ensures that the data you pass into it is serialized to XML and saved to your local object store. And you can also use that to load that same data from XML and use it to get the correct state of your page back. That's one thing it does. The other thing it does is that it allows you to easily save the navigation state of your application, of your frame actually, of the main frame of your application. It actually does that by getting the frame's navigation state, serializing that to XML, saving it in the local object store, and once the application is started again, after being terminated, for example, it can deserialize that and set the navigation state of your main frame, of your frame, to wherever it was the user left off. So that means you not only get the page where the user left off, you also get the pages he was before, so the back button still works. All this actually happens simply by serializing it to XML and saving it in the object store. So Suspension Manager, it's pretty good. But as I said, it's typically something that's used for simple applications, in my opinion. XML, okay, it's good to quickly serialize, but there are better options. You might prefer binary serialization even, or you might prefer JSON. In that case, you would have to either change the Suspension Manager around a bit or write your own implementation. A lot of the stuff the Suspension Manager can be used for is what we will talk about in another part of the session, which is offline mode. So I'm now going to show a demo, and I'm going to use the Suspension Manager's way to save the navigation state in this demo. And in the next session, we'll look into using our own implementation of saving as JSON in this case to save the state of other parts of the application. So let's have a look at the demo. How do you save state and where do you end up? Onto Visual Studio then. So first thing I'm going to show you is the app.xml, of course. Let's make it a bit bigger. Let's see. As you can see, as I said, there are two handlers. Suspending, you can two events. Suspending event, you can add a handler to it. Resuming event, you can add a handler to it. On suspending is typically where we will want to save the frame's navigation state. So that's one thing we have to keep in mind. For this example, when we resume, we will not have to do anything. There's not exactly a need to refresh the data of our demo. If you would have a news app, you would want to do that if a lot of time had passed. And the third way to handle your process lifecycle management through what's included out of the box was the onLaunched method, as I said. So let's have a look at that one. This is the important part here. We always end up in onLaunched, and in the arguments, you can check what the previous state was. So this is what we see here. We can check if the previous state was running, was different from running or different from suspended. And in that case, we're gonna load some data. Otherwise, we don't have to do that, of course. So this is the important part for this demo. If the previous execution state was terminated, which means we end up back in our application after the complete memory dump has been gone, then we need to ensure that our application is back on the page where the user left off. So what we do then is use the Suspension Manager to restore this application state. Now, I'm going to start with this one. First thing we need to do is we need to tell our Suspension Manager that we are going to register this frame with this key. This frame is the root frame of my application, so this is where all my views are displayed in. Once this is done, your Suspension Manager will be able to save the navigation state. So that's one thing I have to do, register the frame we're using. Second thing I have to do is ensure my state is saved. So as I said, that was when I suspend my application. So let's go to did I call it? On suspending. Here we go. So this is actually all we have to do. Save async. This will actually save the complete state of everything you kept in your suspension manager, or you keep track of in your suspension manager. In this demo, I'm only using the suspension manager to save the navigation state. So that's all that will happen here. And the last thing we need to do is, of course, let's see, here we go, restore the state if the previous application state was terminated. So this will ensure that I go automatically back to where I left off. So that's actually 1, 2, and a try catch, 3 lines of code, more or less, to save the navigation state of my application. There's actually nothing else I have to do. It's not that I have to write other code in my views when navigating for this state. Simply by registering the frame, that will work. Of course, there are a few gotchas, which I will immediately come into. But for now, let's see if this works. So I'm building this. So here we go. It loaded my data. And of course, I need to navigate somewhere now. And now I need to ensure my application is terminated to be able to test this. And there's a tip there. This one is called the debug location bar. Be careful because this isn't on by default. So by default, if you're debugging, you will not see this. You can find it, where is it in the view? Ja, where is it?
Rechtermuisknop of zo. In de toebehouden is rechtermuisklik. Dan kunnen we
Yeah, here we go. So right mouse click, and you've got the debug location here. Why is this important? Because this debug location toolbar allows you to suspend your application, resume your application, and suspend and shut down your application. It's the last one we'll need here. By default, your application isn't terminated as long as you have a debugger attached to it. So if you want to check what will happen with your application after you've terminated it, you can do it through this here. So suspend and shut down will make sure your application is suspended, and immediately after that, it will be terminated and removed from mem. So let's have a look at what will happen. My application is running now. So suspend and terminate should end up in suspending. So let's see. Suspend and shut down. Here we go. I'm in suspending, and I'm just going to let this continue, and my application is finished. That means if I now start my application again, previous state will be terminated because my application has actually been shut down, it's been removed from memory. So I'm going to put a breakpoint there. There's already a lot of code in here. There we go. And this is where I should end up in. So in onLaunched. There we go. This is where I end up in every time. And this should be terminated. So let's see. I'm in onLaunched. I'm going to ignore all the other code for now. It has nothing to do with this demo. And here we go. Is the previous execution state terminated? It is. So I'm going to restore my state, which actually means that I end up where I left off. And as you can see, it even saved the state, the previous pages I was on. So I can now simply continue to use my application as if it was never terminated. Now, as I said, there are a few gotchas here. If you've used a navigation framework that's in Windows 8, you might know that it's possible. Let's go to some code which shows this. As you can see here, you might know that it's possible to navigate to another page and pass in any type of object. So you can actually pass in a catalog category in our example, or any other type. Just quite an easy way to work. However, if you do that, your suspension manager is going to fail. Well, actually, it's not the suspension manager that fails, but it's one of the things that the suspension manager uses that fails. As I said, we are saving the navigation state of our frame. It does that by serializing it. So if we go and look at the code of the suspension manager, you get that in store application. So it should be here. Yeah. So let's find the code I'm looking for. Say frame navigation state, that's one of the things it does. Here we go. So what it actually does is it uses the frame's get navigation state method. This get navigation state method serializes the navigation state to a string. The problem is it can actually only serialize the simple types. It can serialize a GUID, it can serialize a string, an integer, but it cannot serialize a complete catalog category or a complete product, for example. Not even if you mark it as serializable and ensure the correct data contracts, etc. are in place. How do you solve this? Well, it's one of two ways actually. Either you do not pass in complete class instances. That's one way. You only pass in IDs and you ensure the other view models get the correct item from your data store, for example. And the other way, if you do want to keep on using passing in complete class instances, you actually have to serialize those yourself. So what you can do, and that's actually a tip or a workaround, let's say, you navigate to, in this case, a type of product category page, and the catalog category you want to pass in. Before passing that in, you serialize it, in this case to JSON. JSON helper.toJSON that actually uses JSON.NET behind screens. So you get that implementation. It's in this exercise. Quickly look at it. As you can see, it's a very simple helper class. So just use JSON convert from JSON.NET to serialize an object and deserialize it. So we use frame.navigate to navigate to the product category page, passing in a serialized version of your class. And of course you need to deserialize it. So let's go to the product category page. And in the load state method here, you catch the navigation parameter and you serialize it back to the catalog category. That's another way of doing this. To be honest, I don't really like having to manually serialize all this stuff myself. So I actually tend to use IDs to pass around instead of passing my complete objects around. But if you really have to do it, you can. Just ensure that if you want to compare objects, that you implement the correct compare, because those are actually two different instances of what now looks like the same thing. But, well, that's just a tip.